A stretch of highway in China just got rebuilt, 158 kilometers of it. That is longer than the distance from London to Birmingham. The road was resurfaced, repaved, and finished to a quality that beat anything a human crew had ever produced on that same stretch of road, and not a single human being drove a single machine to do it. No operators, no drivers sitting in cabs, no workers on the blacktop. Just robots, satellites, and artificial intelligence moving in a formation so precise it looked like a choreographed dance from above. That story alone would be enough to make headlines for a week. But here's the thing. That highway is just one of 8 machines and systems China has quietly built over the last decade. 8 pieces of engineering so advanced, so powerful, and so far ahead of what the rest of the world is doing that engineers from Germany, Japan, and the United States are paying very close attention right now. Some of these machines go places no other machine can reach. One of them walks. One of them sits on the ocean and lifts things the size of apartment buildings. One of them drilled 7 kilometers of tunnel directly beneath one of the most crowded cities on Earth without anyone on the surface feeling a single vibration. This is not about one cool machine. This is about a shift in how the entire world builds things. And by the end of this video, you will see exactly why that shift is already happening. Number 5. The road that built itself. Let's start with the highway, because it is the clearest example of how far things have come. China's Beijing to Hong Kong Expressway is one of the busiest in the country. Millions of vehicles travel it every year. Like all roads, it needed resurfacing. The top layer of asphalt wears down over time, gets cracked and rough, and has to be replaced. That is a normal job. What was not normal was how China decided to do it this time. They sent in robots. The fleet was built mostly by Sany Group, one of China's biggest construction equipment companies. At the center of it was a machine called the SAP 200C-10, an autonomous paving machine that could lay fresh asphalt across a width of 19.25 meters in a single pass. To give you a feel for that number, most highways have lanes that are about 3.5 meters wide. This machine covered 5 full lanes of road in one single sweep without stopping. Supporting it were 9 robotic rollers. 6 of them weighed 13 tons each. 3 weighed 30 tons each. They followed the paver in tight formation, compressing the fresh asphalt layer by layer to make sure it was solid, even, and durable. The whole group moved together like one organism. They did not bunch up. They did not fall out of sync. They did not drift off course. The reason they could do this came down to 2 things working together. The first was China's own satellite system called Beidou. It works like GPS but with better accuracy in certain conditions, and it gave every single machine in the fleet a position reading that was accurate to within a few centimeters. The second was an AI system that processed all of that location data in real time and kept every machine in its correct spot relative to the others. The AI was also watching for obstacles, checking the temperature of the asphalt being laid, and adjusting the speed of the machines dependent on what it found. Here is what made engineers stop and stare. When the job was done and the road quality was checked, the finished surface was not just as good as what a human crew would produce, it was better. The asphalt was more evenly laid, the depth was more consistent, and the surface was smoother from one end to the other. Human crews, even the best ones in the world, deal with fatigue, with slight variations in concentration, with the natural inconsistency of people doing a physically demanding job for hours at a stretch. The robots did not have any of those problems. They ran for the full shift. Every pass was as precise as the first one. The total project covered 157.79 kilometers, and the robots completed it without a single worker setting foot on the active construction area. Safety was another huge win. Construction sites along live highways are genuinely dangerous places for workers. Traffic is close, machines are heavy, and accidents happen. By removing people from the active zone entirely, the risk dropped to almost zero. Now here is where the story gets bigger than just one road project. The Ministry of Transport in China has announced plans to expand this kind of smart highway technology across the country by 2026. And these new roads are not just being built to carry cars. They're being built with sensors embedded in the road surface itself. Sensors that can communicate with electric vehicles, charge them wirelessly as they drive, and feed real-time data back to a central system that monitors the road's condition every single day. The road that built itself is also the road that talks back. Number 4. The crane that moves the ocean. While robots were busy building roads on land, something entirely different was happening on shore. China needed to build a bridge, not a regular bridge, the longest sea-crossing structure ever built on Earth. The Hong Kong to Zhuhai to Macau bridge stretches 55 kilometers across the open ocean. For context, that is roughly the length of 550 football fields placed end to end. The trip between Hong Kong and Zhuhai used to take 4 hours by road. The bridge cuts that to 30 minutes. It has 3 lanes of traffic in each direction, and it is designed to last 120 years, which means it needs to withstand typhoons, earthquakes, and ocean conditions that would tear apart anything built to a lower standard. But the most jaw-dropping part of this project wasn't the bridge itself. It was what happened underneath it. Part of the crossing goes through a tunnel that sits on the actual ocean floor. Huge prefabricated concrete sections had to be lowered to the seabed and connected with such accuracy that the joints between them were watertight. If even one section was placed even slightly wrong, the entire tunnel could leak, and a leaking tunnel at the bottom of a shipping lane is not a small problem. Someone had to lift those concrete sections. Someone had to carry them out to sea. Someone had to lower them into position in the middle of the open ocean, with waves pushing and pulling at the load, with currents running underneath, and with a margin of error measured not in meters, not in centimeters, but in millimeters. That someone was the Zhenhua 30. Built by a Chinese company called ZPMC, the Zhenhua 30 is the most powerful floating crane on the planet. It is almost 300 meters long, which puts it in the same size range as a nuclear aircraft carrier. It carries a crew of 380 people, and its lifting capacity is staggering. It can pick up roughly the weight of 8,000 cars in a single lift, without tipping, without swaying more than it needs to, and with enough control to put that load down exactly where it needs to go. The way it manages this is through a system of sensors, computer controls, and hydraulics that constantly adjust the tension on the crane's cables as the ocean moves beneath the vessel. The load hangs in the water, and the ocean tries to push it around. The system fights back in real time, making tiny corrections continuously so that the concrete section never swings out of position. When the final section of the tunnel was lowered into place on May 2nd, 2017, it had to slot into position between sections that were already sitting on the ocean floor. The gap on each side was measured in millimeters. The Zhenhua 30 held that section in the water and walked it into position with a precision that seemed impossible given the scale of the machine and the unpredictability of the sea around it. Then in 2025, the same crane completed China's first installation of a 10,000-ton offshore wind farm platform. That is a single steel structure weighing 10,000 tons being lifted off a vessel in the open ocean and placed onto a foundation on the seafloor. For the same crane to switch from undersea tunnel construction to offshore wind energy installation shows just how versatile this machine is. The rest of the world takes note of the Zhenhua 30 for a very specific reason. As offshore wind energy grows, the platforms and foundations needed to support turbines in deeper and deeper water keep getting bigger and heavier. Right now, the Zhenhua 30 is one of the only vessels on Earth capable of handling the heaviest of those installations. Countries investing in offshore wind in the North Sea, Southeast Asia, and the United States are already looking at what this machine can do and asking how they get access to something like it. Number 3, the machine that walks, the tunnel that should not exist. Now, we need to talk about 2 machines that seem like they came straight out of a movie, and one of them actually did appear in a science fiction blockbuster because the filmmakers wanted the most extreme real-world machine they could find. First, the walking excavator. The XCM GT 120 is built by one of China's largest construction equipment makers. On the outside, it looks like a mechanical insect. It has 4 legs that each move independently, bending and extending through a set of 18 hydraulic cylinders that let the machine adjust to whatever surface is underneath it. On a flat road, it actually walks quite smoothly. On a steep mountain slope, it lowers one side of its body to keep itself level. In a swamp where wheels or tracks would sink straight in, it spreads its legs wide and keeps its weight distributed across a large enough area to stay on top of the soft ground. It has been tested and deployed at altitudes of up to 4,500 meters, which is higher than most mountains in Europe, and at temperatures as low as minus 40 degrees Celsius. The hydraulics and control systems keep working at those extremes because they were specifically designed for them. The reason this machine exists is not to show off. It exists because there are places in the world where disasters happen that no other machine can reach. When an earthquake hits a mountain region and collapses roads and bridges, when a landslide buries a village and the approach terrain is unstable, when a wildfire tears through steep forest and emergency equipment can't get to where it needs to be, a wheeled machine is useless. A track machine often can't handle it either. The ET-120 walks in. Once it gets there, it does not need to call for backup. The arm at the front accepts interchangeable attachments. Swap in a digging bucket and it clears rubble. Swap in a hydraulic shear and it cuts through collapsed steel beams. Swap in a grabber and it moves debris off trapped people. Swap in a drill and it breaks through rock. A firefighting attachment turns it into a remote-controlled fire suppressant platform that can work inside the fire zone while the operator stays safe at a distance. And that last part matters as much as everything else. The ET-120 is fully remote controlled. The person operating it can sit hundreds of meters away from the danger and drive it using a controller and a camera feed. The machine takes the risk. The human stays safe. This is the machine that appears in the Chinese science fiction film The Wandering Earth 2, which used it because the production team specifically wanted equipment that looked futuristic but was entirely real. They found it. The steel mantis, as people online call it, had already left science fiction behind. Now let's go underground. Below Beijing, China's capital, and one of the most crowded cities on Earth, the ground is not solid rock. It is a shifting mixture of sand, underground water, and soft layers that change in density and composition every few meters. Drilling through it is extraordinarily dangerous because the wrong pressure in the wrong place causes sinkholes to open up on the surface. In a city of 21 million people, a sinkhole is not just an engineering failure, it is a catastrophe. China needed to extend the East 6th Ring Road through the heart of the city, and the only way to do it without tearing up the streets and displacing hundreds of thousands of people was to tunnel underneath everything. The machine built for the job was called Jinghua, and what it accomplished deserves to be talked about far more than it is. Jinghua is a tunnel boring machine over 16 meters in diameter and 150 meters long. It weighs 4,300 tons. To put that in perspective, 4,300 tons is roughly the weight of 700 fully loaded double-decker buses. This machine was assembled underground and moved through the earth at depths of up to 150 meters below the surface, grinding through sand and water and soft soil using a rotating cutter head at the front. The part that makes this almost unbelievable is what was happening above it the entire time. The streets of Beijing. Millions of people going to work, to school, to shops, cars, buses, delivery trucks, buildings standing on foundations that went down into the same soil the machine was moving through, and nobody felt a thing. The control system running Jinghua was monitoring the ground pressure around the machine continuously. It adjusted the speed of the cutter, the pressure of the support system inside the tunnel, and the rate of advance depending on what the sensors told it about the ground ahead. The goal was to remove material from the earth without letting the earth above react to that removal. Every sensor reading was logged. Every millimeter of movement was checked against the planned path. Any drift at all triggered an automatic correction. In its best month of operation, Jinghua pushed forward over 500 meters. That is more than 5 football fields a tunnel through the most challenging urban underground environment imaginable in 4 weeks with 0 incidents on the surface. When it broke through to the other side, Beijing did not notice. People went to work. The streets above were intact, and underneath, a new section of one of the city's most important transport routes was ready to be fitted out. 20 years ago, China did not build machines like this. They bought their tunnel boring machines from companies in Germany, Japan, and France at enormous cost and waited for foreign engineers to come and operate them. Today, Chinese manufactured tunnel boring machines hold nearly 70% of the global market. That is not a small shift. That is a complete reversal of who controls one of the most critical technologies in urban infrastructure development. Number 2, the machines at the extremes. The machines in the last section were impressive because of where they worked. These next ones are impressive because of what they are capable of at an almost absurd physical scale. Start with foundations. Before any skyscraper goes up, before any sea bridge gets its first pillar, before any offshore wind platform goes into the water, something has to anchor it to the ground. This means drilling holes into the earth, deep, wide, precise holes that will support everything placed on top of them for decades or even centuries to come. The XCMG rotary drilling rig is the most powerful foundation drill in the world, and the numbers that describe it take a moment to sink in. It stands 42 meters tall. That is the same height as a 14-story building standing on a single rig. It weighs 520 tons. Its drill bit can cut a hole 7.5 meters wide. That is wide enough to park several full-size cars side by side inside the hole it leaves behind, and it can drill to a depth of 190 meters. Flip a 60-story skyscraper upside down and push it straight into the ground. That is roughly the depth this machine can reach. At the bottom of that hole, 190 meters below the surface, the drill is still controlled precisely by the operator sitting in an enclosed air-conditioned cab at the top, watching a digital display that shows exactly what the drill tip is encountering. When it hits soft clay, the system adjusts. When it hits dense rock, it adjusts again. The operator does not have to guess. The sensors tell the machine. What used to take weeks of work with conventional drilling equipment, this rig handles in days. It has been used to anchor some of the tallest towers in Asia, to set the support piles for bridges that cross open water, and to sink the bases of offshore wind turbines that need to resist ocean storms for 30 years without shifting by more than a couple of centimeters. It has been exported to more than 80 countries. Somewhere right now, on almost every continent, a building or bridge or energy installation is standing on a foundation that this machine drilled. Now go in the other direction. Instead of drilling down, picture digging sideways and at enormous scale. The WK-75 is one of the largest electric mining shovels ever built. It stands nearly 24 meters tall, which puts the top of the machine at the height of a 7-story building. It weighs 2,000 tons. Its tracks, the things it uses to move around the mining site, are taller than a full-grown adult standing upright. If you have ever seen a standard yellow excavator on a road construction site and thought it looked big, the WK-75 would make that machine look like a toy you could hold in your hand. The bucket at the end of its arm holds 75 cubic meters of material in a single scoop. To picture that amount, take 2 full-size 20-foot shipping containers and imagine them filled completely with rock and earth. The WK-75 picks that up, swings around, and dumps it in one continuous movement. It does this over and over again, processing around 12,000 tons of material every single hour. In one full month of operation at a coal mine, this machine pulls 5 million tons of rock and earth out of the ground. It runs entirely on electricity. The equivalent output is 50 car engines running at full power at the same time. 2 separate electric motors power it, one for the digging arm and one for the rotation of the upper body, and they work independently so that the machine can be in the middle of a swing and a dig at the same time. The result is a motion that looks almost graceful for something of this size, smooth and continuous rather than jerky and mechanical. When you watch footage of the WK-75 working, the thing that gets people is the scale. Your brain keeps looking for a reference point, and every reference point it finds looks tiny next to the machine. Now, think about what comes after all that digging and drilling and anchoring. Roads get built, towers go up, mines produce energy, And somewhere, running underneath all of it, are pipes and cables and irrigation channels that were cut into the ground using equipment most people never think about. The Terex M5, a heavy chain trenching machine built for the hardest ground on Earth, is one of the machines that makes underground infrastructure possible in places where normal trenching equipment simply breaks down. Weighing 77 tons, it carries a massive cutting chain attached to a boom that it lowers into the ground and drags forward. Each link in that chain is roughly the size of a brick. The chain rotates and grinds into whatever's below, not through speed, but through an enormous amount of turning force applied continuously against the rock face. At 440 horsepower, and with a GPS guidance system keeping it at the exact depth and direction at every moment, this machine grinds through granite formations that destroy conventional cutting equipment. It moves very slowly. From a distance, it barely seems to be moving at all. But it does not stop, and everywhere it goes, it leaves a clean, straight trench ready for whatever needs to go inside it. Gas pipelines, power cables, water channels feeding farmland. The underground infrastructure that keeps modern life running was put there by machines like this, working through material that had no intention of cooperating. Number 1, the incredible machine that truly connected a nation. Here is a number that puts everything else in this video in context. China's high-speed rail network just passed 50,000 kilometers of operational track. 50,000 kilometers. That is longer than going all the way around the Earth twice. Cities that used to be a full day's drive apart are now less than an hour away by train. Trips of 1,000 kilometers can be done in about 4 hours. The fastest trains are now hitting speeds of over 350 kilometers per hour in regular daily operation. And in late 2024, China unveiled a new prototype that hit 453 kilometers per hour in testing. For comparison, the fastest commercial aircraft travel at around 900 kilometers per hour. China is building trains that travel at half the speed of a commercial jet on tracks across a network that spans the country. 20 years ago, almost none of this existed. In 2008, China opened its first high-speed rail line. Since then, the network has grown so fast and so large that it now exceeds the combined total of every other high-speed rail network in the world put together. That kind of expansion does not happen by laying track by hand. It happened because of machines like the CPG 500. The CPG 500 is a track laying system that works like a rolling factory. Other track laying equipment works in stages, placing a section of rail, stopping, repositioning, placing the next section, stopping again. The CPG 500 does not stop. It moves forward continuously, laying rails and placing the concrete sleepers they sit on at the same time in an unbroken process. In a single work shift, it can install up to 2 kilometers of finished ready-to-use track. It handles individual rail sections up to 500 meters long, a length that older methods struggled with because steel rails that long are incredibly difficult to align and handle. The CPG 500 manages that alignment with a margin of error of only 10 millimeters across the entire run. That level of precision is what allows trains to travel at 350 kilometers per hour safely. The track has to be essentially perfect. The machine makes it so. In March 2024, the CPG 500 completed the first 92-kilometer section of a major Malaysian railway project 1 full month ahead of schedule. In Indonesia, it was used on the Jakarta to Bandung Railway, the first high-speed rail line in Southeast Asia, laying 500-meter-long rail sections and 360-kilogram sleepers at an average pace of 1.5 kilometers per day. It was used on the China to Laos Railway, one of the most complex sections of the Pan-Asian Railway Corridor, and it is currently being used in Europe on the Hungary to Serbia Railway project that is modernizing one of the main rail corridors in the Balkans. The machine has also crossed one of the harshest environments on the planet. The Tarim Basin in China's Xinjiang region is home to the Taklamakan Desert, a place of extreme heat, extreme cold, and near zero moisture. Building anything there is a serious engineering challenge. The CPG 500 laid the track for the first railway line to circle the entire desert, a loop of track through one of the most remote and hostile landscapes in the world, completing what would have taken years of manual labor in a fraction of the time. The numbers tell the story in a very direct way. China commissioned 2,457 kilometers of new high-speed rail in 2024 alone. That is more than the total length of the entire high-speed rail networks in most countries built in a single year. The plan is to reach 60,000 kilometers of high-speed rail by 2030. Machines like the CPG 500 are the reason that is not just a plan, it is a schedule. When you look at all 8 of these machines together, something becomes very clear. This is not a story about cool engineering. It is a story about a country systematically building the tools needed to build everything else faster, better, and in more difficult places than ever before. Think about where each of these machines operates. The robot highway fleet works on live, busy roads. The Zhenhua 30 works in open ocean. The ET-120 walk-in excavator works in earthquake zones, mountain ravines, and swamps. Jinghua worked 150 meters below one of the most densely populated cities on Earth. The rotary drill works in conditions from soft river clay to hard bedrock. The WK-75 works in massive open-pit mines. The chain trencher works through solid granite. The CPG 500 works in deserts. These are not machines built to do easy jobs in easy places. They are machines built to do the jobs that used to be considered almost impossible in the places where nothing else could go. And the global impact is already showing. The CPG 500 is built in rail on 3 continents. The rotary drilling rig has been exported to more than 80 countries. Chinese-built tunnel boring machines hold the majority of the global market for underground infrastructure. The Zhenhua 30 is the go-to asset for the heaviest offshore installations anywhere in the world. What is also worth noting is where China was just 2 decades ago. In 2005, China was buying tunnel boring machines from Europe and Japan. They were paying foreign companies to come and operate them because the skills and knowledge had not yet been developed locally. Today, they're the ones exporting the machines and the expertise. That transition from buyer to global leader in one of the most technically demanding areas of construction happened in less time than it takes a child to finish school and start a career. The Autonomous Highway Project gives a glimpse of where this all goes next. The Ministry of Transport has outlined plans for smart highways embedded with sensors, built and maintained by autonomous fleets, capable of communicating with self-driving vehicles and wirelessly charging electric cars as they drive. The infrastructure itself becomes intelligent. Governments and engineering firms watching all of this from outside China are asking a serious question. If these machines keep getting better, keep getting exported, and keep setting the standard for what construction looks like, what does that mean for how the rest of the world builds its roads, its tunnels, its bridges, its rail networks? The honest answer is that it means learning to build alongside these machines, or building without them and falling behind. If this video showed you something you had genuinely not heard of before, a like and subscribe helps more than you might think. Hit the notification bell so you catch the next one, because we are far from done with the stories that deserve more attention than they are getting. One last thing before you go. Of all 8 machines in this video, which one do you think would have the biggest impact if it showed up and started working in your country tomorrow? Drop your answer in the comments below. I've read every single one.